Welcome to this video on Functional Skills Maths Practice Paper 4 at Level 2. We're going to show you how to do the questions on this practice paper to help with your revision. We're going to start with Section A, which is the non-calculator section, and it's going to take approximately 25 minutes, and there are a total of 15 marks available. Question 1. What is 5/8 as a percentage? Give your answer rounded to 2 decimal places. Well, we can't really use equivalents because 8 doesn't go into 100 a nice number of times. So what we need to do is divide the 5 by 8 and do it to 3 decimal places so we can round to 2. So 8 doesn't go into 5, decimal point, carry the 5. 8 goes into 50 6 times. 6 8s are 48, so it's a remainder of 2. 8 goes into 20 twice, which is 16. So it's a remainder of 4. 8 goes into 40 5 times. So as a decimal, it's 0.625. So as a percentage, 2 decimal places, 62.5. They want 2 decimal places, so I'm going to give them the 0. So 5/8 as a percentage is 62.50. Don't forget the units, which is percent. Question 2. Calculate 12% of 500 grams. So it's the non-calculator paper, so we use the 10% rule. So 10% is 50. Again, level 2, you should know your 1% rule. So 1% is 5. We don't want 1%, we need another 2% to give us 10. So our 12% is our 10% and 2% values added together to give us 60. So it's 60 and the units are grams. Okay, our next question, question 3, work out 2 1/4, subtract 1 1/2. The best way to do this is think of your clocks, because we think in terms of quarter of an hour, half an hour, and so on, is take away the 1 hour to leave you 1 1/4, and then you've got half an hour to take away from 1:15. So if you go back, you end up with 0 and you'd be at 3/4. So the answer to tick is C. Question 4. Work out 2/3 plus 3/7. You can't add them together because 3 and 7 are different denominators, so we need to choose a number they both go into, which is 21. 7 times 3 gives me the 21. The 3 has been multiplied by 7 to give me 21, therefore I've got to do the same to the numerator so that I keep my fraction the same. So 2/3 is the same fraction as 14/21. The same on this side. To get from the 7 to the 21, I multiplied it by the 3. Therefore, the 3 times the 3 is 9/21. So the fraction 3/7 is the same fraction as 9/21. It's just written in a different way so we can do something with it. Add the 2 together and we end up with 23/21. So you can put this for your answer, or if you want to put it as a mixed number, you know that 21 goes into 23 one whole time with a remainder of 2, and the 2 still needs to be divided by 21. So either of these two will do as your answer. Question 5. Bill is a builder and he makes a mortar mix with 24 kilograms of sand and 5 kilograms of cement. The next day he makes the same type of mortar mix. How much cement does he need if he uses 36 kilograms of sand? So this is a parts ratio. Got a ratio between sand, 24 kilograms, and cement, also in kilograms, of 5. He's used 36 kilograms of sand. So how do I get from 24 to 36? Well, I can see that it's 1 1/2 times. If I half 24, I get 12. So I've multiplied this side by 1 1/2. I need to multiply this side by 1 1/2. So I end up with 7.5. So how much cement does he need? he needs 7.5 kilograms of cement. Question 6. Write the number 2.71828 to 3 decimal places. So 3 decimal places means I'm going to cut it off here, but I'm interested in this here. Look at the next number along and decide whether to stick or twist. In this case, you're going to stick because it's a 2. So it's 2.718 for 1 mark. Question 7. Here is a formula. P equals 3t squared. Work out the value of P when t is 10. So P equals 3 times t squared. Swap the t for the number 10. And it becomes P equals 3 times, do the squared first, which is 300. So P is worth 300. Question 8. So we've got some bid mass. B means brackets first, and we've got brackets, so we need to know what's inside the brackets first. We've got multiplication and subtraction, so the division and multiplication comes first. So in the brackets, it becomes 13 minus 8, which is 5. Don't forget outside the brackets, we've got the squared. So now we've got the inside of the brackets, we need to do the outside. 5 squared means 5 times 5. So we have 25 as our answer. Question 9 is getting us to add 2 decimals. So use the column method and line up the decimal points. If you've got a difference in the number of decimal places, infill with a 0. That goes for subtraction as well. Now, 0 and 2 is 2, because we're adding. 9 and 5 is 14. 4 and 4 is 8, plus the one we carried is 9. The decimal point goes in. 8 and 7 is 15. 7 and 2 is 9, plus the one we carried is 10. And 3 plus the 1 plus the one we carried is 5. So our answer on the answer line, 505.942 for 1 mark. Question 10. Lizzie buys 3 clocks for a total of £50 at a car boot sale. She sells 2 clocks for £22 each and the other clock for £20. How much money did Liz get for the 3 clocks in total? So we're just adding 2 lots of 22 and the 20 for the third clock. So she got £64 in total. How much profit does Lizzie make? So we've got the £64 that she's made. We take away the £50 that they cost, and you have a profit of £14. And that's worth 1 mark. Lizzie thinks she's made a profit of over 30% on the clocks. Is she correct? Show why you think this is. So what we need to do is take a percentage change is equal to the difference divided by the original times 100. So the difference between the prices is our profit. The original price was 50 and we multiply by 100 to turn it into a percentage. So we don't do that, we do that, and 100 divided by 50 is 2. 14 times 2 is 28% profit. So is she correct? No, she is incorrect. She made just 28% profit. Question 11. Usha is a local councillor. The diagram shows the space for the new development. Usha thinks the area of the new development is approximately 30,000 meters squared. Is she correct? And show why you think that is. So we have to work out the area of a triangle, and it wants us to do it approximately. So we'll use estimation. We'll make this side 100 meters, and we'll make this side 300 meters to make the maths easy. So the area of a triangle, you multiply the 2 dimensions. So 100 times 300 is 1 times 3 is 3, with 1, 2, 3, 4 zeros. Now, don't forget, because it's a triangle, we need to divide this by 2. So it's 30,000 divided by 2 gives us 15,000 meters squared. So she thinks it's going to be 30,000. She's actually forgotten to divide by 2, and it's 15,000. So no, she is incorrect. And the evidence for that decision is our calculation up there for the area of our triangle. And that's worth 1 mark. B. Here is a diagram showing the space of each house that needs to be approved for the building of this new development. Calculate the area needed for each house. So we have 15 meters here, and we have 11 meters there. So to calculate the area, we multiply the 2 dimensions. It hasn't asked for an approximation, so we have to do this properly. So we need to work out exactly 15 times 11. So use whichever method you prefer. So I've got 15 times 11. 10 tens are 100, 10 fives are 50, 10 ones are 10, and 1 5 is 5. And I get 165 meters squared as my answer. Question 12. This table shows the salary for each employee working at a company. And here are our salaries. And that's in thousands of pounds. Calculate the median salary at this company. So median is the middle, and we need to sort it. So start with our smallest amount, which is 17. Then we have 2 18s. Then we have a 23.5, a 24, 24.5, a 25, a 26, and a 36. Oh, sorry, a 35. Okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So we're expecting to see one number in the middle. So cross them out from the ends, and you end up with 24,000. So 24 is the number. It says the median salary, so 24, and don't forget it's in thousands. So £24,000 is the median salary. And that completes section A, which is worth 15 marks. Okay, now let's have a look at section B. This is calculator is permitted, and you have 1 hour and 20 minutes, and there are a total of 45 marks available. Question 1. This graph can be used to convert between gallons and litres. Convert 60 litres to gallons. So go to the 60, draw a line up, and then, using a very accurate ruler, go across. So we've got 10, 11, 12, 13 gallons. Don't forget your units. Anya used 44 litres of fuel. Mira used 8 gallons of fuel. Anya used more fuel than Mira. Use the graph to work out how much more. Doesn't tell us which units to work in, so we'll take Anya's 44 litres and let's go and look up the 8 gallons for Mira. So we go to 8 gallons, we draw a straight line across and down, and it tells us she's used 3246, so 36 litres. Do this on your calculator, and there are 8 litres difference. So Anya used more fuel. How much more? 8 litres more. And that's worth 2 marks. Question 2. David reads this advert in his county council's website. 70% of the area of woodland in the countryside is native woodland. This means there are 350 square kilometres of native woodland in the county. Work out the total woodland in the county that is not native woodland. So we've got a relationship between native woodland and not native woodland. We know that the native woodland is 70% and it goes to 350 kilometers squared. So the not that we've been talking about is 30%. So if we divide 350 by 70, it will give us our scale. And the scale is quite nice, it's 5. So we multiply the other side by 5. To get our kilometers squared. So work out the area of woodland in the county that is not native to woodland. And we've worked out that our 30% is worth 150. And don't forget the units are kilometers squared because we're talking about the area. So 150 kilometers squared. Question 3. Here is a pentagon. So all a pentagon is a 5-sided shape. The pentagon has one line of symmetry. Work out the size of the angle marked X. So what it's saying is if this is exact, then this must be the same as this. If this angle here is 125 degrees, we know that the square part of it is 90. So 125 minus 90 is 35 degrees. If that's 35 and this is an isosceles triangle, then that's 35. So to find X, the triangle is worth 180. We're going to take away 2 lots of 35 and it will tell us what the angle X is. So we've worked out that X is 110 degrees. So for 3 marks, some working out to find this angle here, to be aware that this is an isosceles triangle because it has one line of symmetry, and then to take the 2 lots of 35 away from the 180 to get your answer of 110. Question 4. The scatter graph diagram gives information about the temperatures at 8 different heights up a mountain. So we have the temperatures and the heights. At a height of 1,000 meters, the temperature is minus 13. Plot this information on the scatter graph. So at 1,000 meters, we have a temperature of minus 13. So minus 10, 11, 12, 13. So that's worth 1 mark. Draw the line of best fit on the scatter diagram. So it's got to go through all of our points and from edge to edge. So let's do that. So I've drawn my line of best fit, so I've tried to keep it between all of the crosses and go as close to as many as I can. So that's worth 1 mark. And then use the line of best fit to estimate the difference between the temperature at a height of 550 meters and 950 meters. So let's have a look at those 2 values on our line of best fit. So 550 is here and 950 would be there. You draw the line across, so roughly minus 6 degrees. Draw the line across and you get minus 12 degrees roughly. So what's the difference between these? I've got minus 12 on my number line. I've got minus 6 with 0. So I've got a difference of 6 between these. So 6 degrees C is the temperature difference. And that question is worth 2 marks. Question 5. Nicola wants to put a flat roof onto a bike store. The roof will be made of concrete and in the shape of a cuboid as shown. Nicola wants to put a metal strip along the side of the longest edge of the roof. She knows the density of the concrete is this and the mass of 1 meter of metal strip is that. Work out the total mass of the concrete and the strips that she wants. So the density of the concrete is in kilograms per meter cubed. So we need to work out the volume of the concrete in meters. So we've got 2 meters. So the volume of the concrete is 2 meters times 3.5 meters times, now this needs to be converted into meters. So 12 centimeters divided by 100 is 0.12, and that's now in meters. So 0.12. Put this in your calculator to calculate the volume of our concrete. 0.84, and that's in meters cubed. So we can now use this. So the mass of the concrete, because it's a relationship, this is a relationship here in a ratio, kilograms to meters cubed, and it's 2,300 kilograms for every 1 meter cubed, per 1 meter cubed. We haven't got a meter cubed, we've got 0.84. So we've multiplied this side by 0.84. We need to do the same on the other side. So 2,300 times 0.84 equals 1932, and that's kilograms. So the weight of the concrete, the mass of the concrete, is 1932 kilograms, and we'll just write that there for now. What she also needs is the mass of the 1 meter of metal strip is 5 kilograms. So we need to know how much of the metal strip there is. So the metal strip is along 2 of the longest edges on the roof. Well, one edge here is 3.5 meters, and I'm presuming that's the other edge at 3.5 meters. So in total, she needs 7 meters of metal strip, because we've got 2 3.5 meter strips, because they're our longest edges. Now 1 meter of the metal strip is 5 kilograms. We haven't got 1 meter, we've got 7. So multiply the 5 by the 7 and you end up with 35 kilograms of metal strip. Scroll down and work out the two masses. So concrete is 1932 kilograms and the metal strip is 35 kilograms. And that question is worth 5 marks. Question 6. Mai has this information about 100 flowering plants in her shop. She will take a plant at random from these plants. Work out the probability that this plant will have large flowers and a long stem. So the stem length are short and long, and they are small and large plants. So the total number of plants is going to add these totals. So we have 53 and 47. Add them together, and that's the 100 that we've got here. Now, 100 is our total. So when we're doing our probability, it's what we want divided by the total. So the probability the plant will have a large flower, so a large flower and a long stem. So there are 29 out of the 100 plants that have this combination. You've created a fraction, so just to check, put it in your calculator to see if it simplifies, and it doesn't because 29 is a prime number. So your probability that the plant will have large flowers and a long stem is 29 out of 100. Mai will take at random a plant from the 72 plants that have large flowers. What's the probability that this plant will have a short stem? So if we go back to the table, the total for the large flowers is 72. So the total number of plants from the 72 is your total. How many have a short stem? So a short stem, large flower, 43. 43. So the total is 72. What we're interested in is 43. Stick it in your calculator to see if it simplifies. And again, the prime number means it doesn't simplify. So 43 over 72 will get you the 1 mark for that question. Question 7. Sal works in a dress shop. She wants to know how well the labels on the dress hangers agree with the size of the dresses. The table shows the information. Sal thinks that 2 in every 7 dresses are on hangers with the wrong labels. Is Sal correct? Show clearly why you think this. So we need to work out how many of the total number of dresses have the wrong labels. So the total number of dresses we need to add up. So the sum is 77. 77 dresses in total. So now what we've got to do is work out how many dresses are on the wrong, have the wrong label. So the 10 and 10 have to match up, so they're the correct label. So we have 4 in this little group that are wrong. The 12 and 12 match up, so we have another 4 here. The 14 and 14 match up, so we have 7 in these groups. The 16 and 16 match up, so we have 3 in this group. And the 18 and 18 match up, so there are 4 that are labelled incorrectly. So the total from these smaller numbers that are incorrectly labelled are the total of 4, 4, 7, 3 and 4. So add them together and that's 22. So we have a relationship of 22 in every 77. Now we've established that relationship, we can try and simplify it. So if we divide this by 11, we end up with 2 in every, so we're going to divide by 11 to simplify it, 7. So is Sal correct? Show why you think this. Yes, she is correct. And then the evidence for this is our working out that we have up here. Question 8. James has a contract to paint 30 identical water tanks. He has to paint the outside surface of each tank, but not the top. Each surface is rectangular.
James knows that 1 tin of paint
is enough to cover 12 meters squared, and it costs $26.99. Work out the total cost of the tins of paint he will need for the 30 water tanks. Okay, so it's a surface area question and we're not going to paint the tops. So we're looking for 5 of the surfaces on this water tank. So let's break them down then. So we've got the right hand side, which is 0.8 by 0.6 of a meter, and we need it in meters for our area. So 0.8 times 0.6 is 0.48 meters squared. Now that's this right hand side. So we've also got the left hand side, which is the same. So if we multiply that by 2, we've got the right and the left sorted. So 0.96, and that's in meters squared, and that's the right hand side and left hand side done. Let's do the front and the back of our tank. So front first is 1.1 meter times the height from there to there, which is 0.6 of a meter. And that's 0.66 meters squared. We've got the front and we've got the back, so we're going to multiply it by 2. And that's 1.32 meters squared. Finally, we need to do the bottom. So the dimensions for the bottom is 1.1 meter for the length multiplied by 0.8 of a meter, which is the depth. And we end up with 0.88 meters squared. We're not going to multiply it by 2 because we don't want the top as well. So now for one tank, we have
the 5
surface areas of the tank. Add them together on your calculator and you end up with 3.16 meters squared per tank. We've got the surface area of one tank and we know we need to paint 30 of them. So 3.16 times 30 means 94.8 meters squared is the total area he has to paint. So now we can work out how many tins of paint he needs. So we've got 94.8 meters squared divided by the coverage for one tin of paint, which is 12 meters squared, which is 7.9. We can't buy 7.9 tins, so rounded up is 8 tins of paint, and then 8 tins of paint at £26.99 is £215.92. So the cost of the job to paint these 30 tanks is £215.92. And that question is worth 6 marks. Question 9. Andros has an oil-fired heating system. In a 30-day period, he uses a full tank of oil at a constant rate per day. At a different time of year, the amount of oil Andros uses per day is 1/3 of the rate he used for the 30-day period. How many days should a full tank of oil last at this new rate? This is an inverse proportion. We've got days, which is a 30-day period, and we've got the amount, let's call it 1. So the amount on this side is going to reduce, so it's going to go to 1/3. So we've multiplied this by 1/3. So we need to divide this side by 1/3, and you end up with 90 days. So 90 days is the amount. So this is a inverse proportion question. So the slower he uses it, the longer it lasts. Question 10. Lena recorded the number of late trains at a station in a day over a period of time. She shows this information in this diagram. So we have the number of days and the number of late trains in a day. So here it gives us a key where there were 2 days when 4 trains were late. So there were 2 days for 1 late train, and there were 4 days for 2 late trains. Work out the median, which is the middle number of late trains in a day. So the number of late trains in a day is, there was 2 lots of 1, then there are 4 lots of 2. Then there are 3 lots of 3, then 2 lots of 4, then 2 lots of 5, 1 lot of 6, no 7s, no 8s, and a 9. So can you see how we've changed the data from the table into just the raw data that created it? So there were 2 1s, there were 4 2s, there were 3 3s, and so on. And all we've done is we've created the data that this table represents. So now, to find the median, we have to cross them off from the end. So the median number is 3 trains. Okay? Because our data is in trains. Question 11. Joanna is a landscape gardener. She has to fill a circular space with flowers. So here's our circular space. The radius is 4.5 meters. Joanna will put 40 flowers per square meter. So there's a relationship. She will plant 4 times as many flowers, red flowers, as white flowers. Another relationship. And then how many red flowers will she plant? So let's work this out then. Let's move it down a bit to get some space. Okay, so we need to work out the area of our space. So the area of a circle, you're not going to be given this, is pi r squared. Take pi as 3.14, the radius is 4.5, and we need to square it. So put this in your calculator and work out what the area is. That's 63.585 and it's meters squared. Joanna plants 40 flowers per square meter. So we've got the number of flowers and square meters. So 40 flowers per 1 square meter. So once we've set up our strap line, we know that we've got 63.585 square meters. So we've multiplied this side by that number. Do the same on the other side, 63.585, and it will tell us how many flowers we need. So 40 times the 63.585 gives us 2,543.4 flowers. We can't have 0.4 of a flower, so let's round it up. So rounded up. So our final relationship is there are four times as many red flowers as there are white. So there are 4 of these for every one of these, 4 times as many as that. We have our total number of flowers here, so this is a totals ratio. So we need to divide that by 5, our total number of parts. And our scale is 508.8. So let's just do that. 508.8 and 4 times 508.8 is 2035.2. I've left the decimals there so that we can do the rounding. So rounded, we have 2036 plants because we can't have 0.2 of a plant, and we've got 509 plants. So red 2036, white 509. So how many red plants does she need? 2036 red plants. And that's worth 5 marks. Jim owns a small business. The table shows information about the weekly wage of the 40 workers. Jim wants to increase the mean wage by 4% plus £10. Jim thinks the new mean weekly wage of these workers will be more than £415. Is Jim correct? So we've got the weekly wage and we've got the number of people at that wage. So we need to multiply them together to work out the total wages that are being handed out to the workers. So to work out the mean wage, you take the total wages being paid and divide it by the number of workers. Which gives us 392.5. Now, he wants to increase this by 4% and then add £10. So let's give ourselves a bit of space. So we've got 4% increase, so 4% of 392.5 is, stick this in your calculator as it looks. So 4 shift percent button of the £392.5 equals SD it 15.7. So we need to add to our original amount the 4% increase, which is 15.7, which is £408 and 20 pence. We need to add another £10. And by the time we've finished that, our calculation in money gives us £418 and 20 pence, which we need to compare to the 415. So, is Jim correct? Yes, he is correct. And then you could say, if you wanted to, it is £3 and 20 pence more than the £415, whatever you want to do there. And that's the end of section B and the end of practice paper 4 for level 2. If you have any questions, please don't hesitate to ask your tutor. I hope this video has been of some use to you.